graph a circle given the center and the radius. You even know how, if you're given a circle in general form, how to complete the square twice to find the center and the radius and then graph it. What we're going to add to circles that we haven't done yet is naming the domain and range. Okay? And so with parabolas, not only are we going to name the domain and range, we're going to also state where the function is increasing, where it's decreasing, where it's positive, where it's negative, and what the end behavior of the graph is. So this is looking at a graph and interpreting things, okay, and then stating on what intervals those things happen. So standard form of a circle is x minus h squared plus y minus k squared equals the radius squared. H and k represents your center, and it also represents the horizontal and vertical shifts, how that circle is transformed, right? And so if we take this first example, we have to write the standard form of the equation. Okay, so this is h and this is k, and the radius is 2. So it's x minus 3, because h is 3 squared, plus y what? Plus 2 squared equals 4. Okay? So now, let's graph it. So now the center's not at 0, 0, because that's the parent graph. The center is now at positive 3, negative 2. So it's right here. The radius is 2. So from the center, we're going to go up, down, left, and right 2 units. Okay? So up 2, left 2, right 2, and down 2. And then we'll roughly sketch that circle. You always want to show, label the radius in that circle. So that's a semi-proper graph of that circle. Now, what we haven't done yet is naming the domain and range of a circle. The domain is how far left and right does that graph go? What's your smallest value of x and what's your largest value of x? Okay? Now, with circles doesn't go forever in any direction, right? So when we're looking at our smallest value of x, if the center is right here at 3, my smallest value is what? My smallest value is 1 because I went to the left 2 units, right? My largest value is 5 because I went to the right 2 units. Now, this was easy to see because the center was exactly on a whole number unit and the radius was a whole number unit. So that was easy to see. But what if the radius was the square root of 2? How would we figure out what's the largest and smallest x value? You can't put it in your calculator because you can't, no, that doesn't work. But that does work. Take the x value for your center and add your radius and then subtract your radius. And that'll give you your smallest and largest values of x. That makes sense? No. My radius is 2. The x value for my center is 3. So if I add 2, I get the largest x value, and if I subtract 2, I get the smallest x value. So it doesn't matter what the radius is. If you add it, see what I'm saying? Yeah. So to find the domain, we'll take our x coordinate for the center, which is 3, and we'll add and subtract the radius, which is 2. So 3 plus 2 and 3 minus 2. That'll give me my largest x value and my smallest x value, right? So x equals 1 and x equals 5. Okay? So now, the way we write it is we're stating x has to be, the smallest value is 1, the largest value is 5. So for circles, we do this. X is between your smallest value and your largest value, 1 and 5. It's always less than when you're trying to say that something is between two things. Okay? Now, does it equal 1 and does it also equal 5?
Yeah.
Yes, it includes those. It includes 1 and it includes 5, so you'll say less than or equal to for both of them. Okay? The only time it doesn't actually equal it is when it's approaching an asymptote, and then it never touches it. Okay? The range is we're looking for our smallest value and our largest value of y. So how high and how low does that circle go? We'll apply the same concept. So we're going to take what and add and subtract our radius? The y value for the center, right? So -2 plus or minus our radius, okay? So, and our radius is 2. That gives us our largest and smallest y value. So y equals -2 plus 2 is 0, and y equals -2 minus 2 is -4. So y is between -4, you want your smallest one on the left, and your largest on the right. Now, let's review. When I ask, where is the function positive, where is the function negative, where is the function increasing, where is the function decreasing? Let's talk about increasing and decreasing first. Increasing and decreasing. Now, when I ask you where is the function blah, 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 I'm really asking you about where is the y values this. So where is the function increasing? Where are the y values increasing? Increasing is like you're going up a roller coaster. Decreasing, you're going down, right? If I'm asking you, where is this function increasing? Can I answer that question? No, why? Because it's not a function. This is not a function. You cannot answer that question. This is not a function because you cannot answer that question. Where is the function increasing or decreasing? It is. You have to recognize that you cannot tell me definitively where this, when I answer that question, I have to say it's increasing between when x is from here to here, or it is this, all the y values are increasing from x equals 2 to x equals whatever. Okay? Let's look right here. This little piece right here, it's increasing, right? It's going up. So if I say when x is 2, y is increasing. But wait, right here, these y values are getting smaller. So when x is 2, that's this point right here, y is increasing, but down here it's decreasing. So you can't have it both ways. You can't have, for one value of x, it be both increasing and decreasing. Okay? That doesn't make sense. Okay? And so, when it's not a function, those answers won't make sense.
But, wouldn't there be some answers that...
This one won't make sense for increasing or decreasing at all. Positive and negative means where are the y values positive and where are the y values negative. Now, it looks like you could answer that for this one, which you kind of can. What are all of my y values in this one? All my y values are negative. So you would say it's never positive and never negative. But if I had a circle like that, for this circle right here, if I said, where is this positive? Well, let's say x equals -3. Is y positive or negative when x equals -3? It's both. It doesn't make sense. Okay? So, although it may look like you can answer the question for the red circle, because it's not a function, you stop there. If it's not a function, don't even try to answer positive, negative, increasing, decreasing, or in behavior. There's no in behavior. There's no end to a circle. Okay? Just keep going. So if it's a circle, the only thing you can answer is domain and range, center and radius. That's it. Okay? Simple. So we also, what's another way that we know that that equation is a circle? Yes. X and Y are both squared. If X and Y are both squared, that's a circle. If only one of them is squared, it's a parabola. Okay? All right. Now, I want y'all to do this one. Tell me the center, the radius, the domain, and the range. So you have to complete the square twice. So we say x squared minus 4x plus blank plus y squared plus 6y plus blank equals, bring the 12 over, 12 plus blank plus blank. So half of 4 is 2, 2 squared is 4, add that to both sides. Half of 6 is 3, 3 squared is 9, add that to both sides. So write that as a binomial, so it's x minus 2 squared plus y plus 3 squared equals 25. So my center is 2, negative 3. My radius is 5, because you have to take the square root of that, because that radius is already squared. Now, you don't have to graph it to tell me the domain and range. Okay, we learned how to do that. You take your x value, add and subtract your radius. That gives you the domain. Take your y value, add and subtract your radius. That gives you the range. Okay? So my domain is 2 plus or minus 5. So that's 7 and negative 3. So I'll say x is between negative 3 and 7. Okay, and my range, we're going to take our y value and add and subtract the radius. So negative 3 plus or minus 5. So that will be negative 8 and 2. So y is between negative 8 and 2. Okay, now let's go to parabolas. Now, we did quadratics. We already grabbed some quadratics before. Okay? Sorry. The axis of symmetry is a line that divides the parabola into symmetrical pieces. Okay? If your parabola is opening up or down, then that line is going to be, the equation of that line is going to be x equals something. It's going to be x equals the x value of your vertex. The vertex is h and k. It's represented by h and k. Your vertex is either a maximum point or a minimum point. It's either the highest or the lowest, depending on how that parabola is opening. If it's opening up, then this is your minimum point. It's the lowest point. If it's opening down, then that vertex is a maximum point. What we haven't dealt with yet is parabolas that open left or right. Okay? The way that you distinguish between the two is if the equation is y equals, your y-axis goes up or down, right? Y equals, that means your parabola either opens up or down. Okay? What do you think determines whether it opens? In this formula, what do you think determines whether it opens up or down? A. A is going to determine whether it opens up or down. What do you think A, how does A determine that? If it's negative, it's down. Why? Because it's a reflection. Right? The parent graph is up. So if A is negative, it's reflected down across the x-axis. Okay? Okay? The parent graph opens up. So A is positive. If A is negative, that means it's reflected. So it opens down. Okay? So if A is positive, that's not an A. So if A is greater than 0, it opens up. If A is less than 0, it opens down. And first thing you do is it x equals or y equals? If it's y equals, that means it either opens up or down. In line with your y-axis. Meaning, y is your non-squared term. Okay? Any questions? Okay. So here's a parabola that either opens left or right. Okay? We know it opens either left or right because it's x equals. Your x-axis goes left and right. So if it's x equals, it's either going to open left or right. What do you think determines on whether it opens left or right? A. The parent graph of that opens positive to the right. So if A is negative, it opens to the left. So in both cases, if A is negative, it either opens to the left or down. If A is positive, it either opens to the right or up.
If it's x equals.
Which brings us to the fact that if it opens left or right, it is not a function. If it is not a function, the only thing you can tell me is the vertex and the domain and the range. You cannot tell me increasing or decreasing because, look at this one. As I go from left to right, it's increasing and it's also decreasing. So you can't say when x is greater than 2, it's increasing. Okay, just like we can't name where it's positive or negative. Because if this parabola was right there, at this point, it's positive and it's negative. So you can't name positive and negative. You also can't say in behavior. Because if I say, as x gets larger, what's y doing? Well, up here, y is getting larger, but down here, y is getting smaller. So the answer can't be both. So if it is not a function, you cannot answer the question, where is the function anything? Because it's not a function. So you just say, not applicable. Let me put this back. That's not it. Okay. All right. Any questions? What else do we notice about this? What's different? The h and k are different. Remember that the number in parentheses with that variable determines how it moves along that axis. So this is saying it shifted so many units on the y-axis. That's your vertical shift. So that's your y-coordinate for your vertex. Okay? This h is your x-coordinate. X equals whatever that is. That's your x-coordinate for your vertex. So you have to be careful. When it's x equals, don't just automatically say the vertex is this, because they're switched. X and y have to be in the proper place. H is your x-coordinate for your vertex. K is your y-coordinate for your vertex. Okay? Let's practice. Now, here's the first example. It's already given to you in beautiful vertex form. With quadratics, there's 3 different forms. There's vertex form, where if it's in this form, you can pick out the vertex. You can cherry pick it out, the vertex. Standard form is ax squared plus bx plus c. Standard form, you can't pick anything out of standard form. But a lot of times after it's already distributed and expanded and distributed, it's back in standard form. The third type of form is intercept form. The intercept form is factor form. So if you took a quadratic and you did the AC method, you ended up with x plus 2 times x minus 4. That's intercept form. because you can look at it and pick out the x-intercepts, the solution, right? So that's intercept form. You want these to be in vertex form so that you can pick out the vertex, because that's what the problem's asking you to do. Okay? If they're not in vertex form, you have to get it in vertex form. Which, if it's given to you, say, in standard form, where it's ax squared plus b, you have to complete the square to put it in this form. Now, what's different for you that you haven't seen till now was that you have to look at the problem. Now, this one's already there, so we don't have to worry about it. But you have to look at the problem and say, what am I solving for? Which one is my non-squared term? Okay? So your non-squared term is the one you have to get by itself. And then that's going to tell you whether it's left or right or up or down or things like that. Okay? So, this one's already in vertex form for us. So, first of all, it's y equals. Does that open left, right, or up, down?
Up, down.
Up, down? Does it open up or down? It opens up, because there's still an A there. A is just 1, right? That's positive. So it opens up. Now, the vertex, the number in here, this is my x coordinate for my vertex, because it's with x. So what's my x coordinate? Positive 3 and negative 2. So positive 3 and negative 2. So I'm going to plot that point. 1, 2, 3, 1, 2. Now, we know it opens up, but I don't want to draw it just yet, because if it opens up or down, you need to know where it crosses the x-axis. Why would I need to know where it crosses the x-axis? Which one of these questions makes that important? Not domain range. Wait.
Oh, no, axis of symmetry.
Positive and negative. When you cross over the x-axis, it changes from positive to negative. Right? So, when you're above the x-axis, y is always positive. When you're below the x-axis, y is always negative. So, that point on the x-axis is where it changes, where it transitions from positive to negative. So you need to know what that point is. Okay? So, now, if it opens left or right, that point is irrelevant because it's not a function, so you can't answer that question. But if it opens up or down, you need to know those x-intercepts. Now, how can you use your calculator to find those? Yes? Oh, that's a good idea. We'll talk about that in just a second. What function in our calculator helps us do that? Calculate 0. That tells us the x-intercept. Okay? What he said was, so put this in as y1, the second equation, put y equals 0, and then calculate the intersection. You can do that too. I'm going to do it algebraically in case someone doesn't have a calculator that can calculate the 0. So if we're going to find the x-intercept, what do we have to let equal 0? You can't let x equal 0 because then you can't solve for x. You have to let y equal 0. You have to let y equal 0 and solve for x. And then whatever x is, that's your x-intercept. So we're going to I'm going to do it algebraically. You're welcome to do it in your calculator. We're going to let y equal 0 and solve for x, and that'll tell me my x-intercepts. So 0 equals x minus 3 squared minus 2. So I have to add 2 to both sides, right? So positive 2 equals x minus 3 squared. What now? No, you don't want to expand it. You're going to get back where you started. Then if you expand it, you're going to make a bunch of x's.
Square root it.
Square root. Perfect. Square root both sides. When I take the square root of both sides, I can't forget what? Plus or minus. So, plus or minus the square root of 2 equals x minus 3. Last thing, add 3 to both sides. So we'll have 3 plus or minus the square root of 2 equals x. Okay? So I'm going to calculate what those are so I can know where to put those dots on the x-axis. So I'll do 3 plus the square root of 2 and 3 minus the square root of 2. So x equals 3 plus the square root of 2, which is approximately equal to 1.6. And x equals 3 minus the square root of 2, which is approximately equal to 4.4. So now I can accurately, semi-accurately, plot those points on my x-axis and then draw the parabola. So 1.6 is about somewhere in that vicinity, and 4.4, 1, 2, 3, 4.4, somewhere in that vicinity, and this is what it looks like. Yes. Okay, so now we have all the information we need to answer all these questions. So, is it a maximum or a minimum? A minimum. It's a minimum. The axis of symmetry. It's that line, and you show it by a dotted line, and that is the line x equals 3. Okay? If it was opening left or right, it would be y equals whatever goes through the vertex. The domain. Yeah, how far left does it go? Forever. How far right does it go? Forever. So the domain is all real numbers. If your parabola opens up or down, your domain's always going to be all real. Okay, the range. What's the range? Y is greater than -2. That's my lowest point, right? So y is greater than -2. Or equal to -2. It does equal -2. Okay? Now, your range is the only thing you're going to name in terms of y. Everything else you're describing as intervals on the x-axis. Okay? So, increasing. It says, where is the function increasing? That means, where are my values of y increasing? For what values of x are my values of y increasing? So you do this as you go from left to right. So, as I'm traveling down here, is it increasing or decreasing? Decreasing. Decreasing, decreasing, decreasing. Then it changes. Increasing, increasing, increasing. So, where is it increasing? After x equals what? 3. Okay? So, x greater than 3. That's where my values of y are increasing. So it's increasing, x greater than 3. We don't say equal to 3 because at 3 it's neither increasing or decreasing. Where it stops is where it changes. So, decreasing, x less than 3. So, all on this side is where it's decreasing. X less than 3. Now, positive and negative. Positive. Where are my y values positive? Now, this is where I said those x-intercepts come into play. Let me label those. This was 1.6, and this was 4.4, approximately. Okay? Now, my y values, is my y value here positive or negative? What about here?
Positive.
What about here?
Negative.
What about here?
Negative. Positive. Positive.
Okay, so those two pieces are where my y values are positive, right? if I took a string and tied it from my graph and connected it down to the x-axis, how would I describe those x values? It's two separate pieces, right? All of these x values, y is positive. And all of these x values, y is positive. Right? Y'all see that? It's going, all of those are positive. All of these are positive. Okay? So, I have to name two separate pieces. So, I have to say, first, when x is less than 1.6, and then you use the word or, because or means you include both graphs completely. Or x is greater than 4.4. So that's when my y values are positive. When x is less than 1.6, or when x is greater than 4.4. Everybody see that? Now, it's negative down here, right? That's that interval of x. So when x is between 1.6 and 4.4, that's when y is negative. Right? So we say, and you do between 1.6 and 4.4. So this section right here is where, for all of those x values, y is negative. That make sense? Okay, so this problem, we can't do anything until we just have a single variable equals, okay? And for this one, we need y equals. Y is my non-squared term, okay? So how do I get y by itself? Multiply by 4, right? So we multiply by 4 on both sides, and then we end up with y equals 4 times x minus 2 squared, okay? So when you multiply by 4 on both sides, you just created the a on the other side, okay? And so now we can answer those questions. So y'all go ahead and do this. Answer those questions. Okay, so it's y equals. So that means it either opens up or down. And a is positive, so that means it opens up. My vertex, the x-coordinate for my vertex is positive 2, and my y-coordinate is 0. See, there was no k, so that just means it's 0. And so 2, 0 is right here, so that's my vertex, and I know it opens up. Now, since it opens up, and it's on the x-axis, we don't need to worry about the x-intercepts, right? Because if I'm going to tell positive or negative, the whole thing is positive. Well, almost. The whole thing is positive. But, is that a maximum or a minimum? It's a minimum, okay? Now, this is the point 2, 0. My axis of symmetry is x equals 2. My domain is all real. My range is greater than or equal to 0. It is increasing starting at x equals, good, it starts at 2 and it's increasing everything after that. So x greater than 2. It's decreasing for all the x values less than 2, because see, it's going down, down, down. So x less than 2 is decreasing. Now, it looks like the whole thing's positive. It's positive for all real numbers except which one? Except for x equals 2. Because when x equals 2, y is 0, and that's neither positive nor negative. So, we say all real numbers except x equals 2, or you can say except 2. So it's positive for every value of x except 2. And is it ever negative? No. So not applicable. Now, end behavior. Over here is what the template for end behavior looks like. As x approaches infinity, y approaches what? As x approaches negative infinity, y approaches what? What that means is, as x gets larger, what's happening to y? And as x gets smaller, what's happening to y? The easiest thing to do is look at the ends. These are the ends. Where is this end going? Up. It's going all the way to positive infinity. Where's that end going? Up. So my end behavior, now this problem didn't ask, but if it did, the problem would look like this. X approaches infinity, or we can say as x approaches infinity. Now it might say y, or it might say f of x. Those are the same thing. They're interchangeable, right? Y approaches what? And your answer would be infinity. That means as x gets larger, y gets larger. And then as x approaches negative infinity, what happens to y? Y also approaches positive infinity. As x gets smaller, y still gets larger. Okay? Any questions? Okay, good. Yes. Yes. Now how much just bunch this? Okay. Y'all ready? Next one. The first thing you have to determine is how are you going to rearrange it? X equals or y equals? Which one is squared? X is squared, so you want y equals. You want y by itself. Okay? So you have to get everything else to the other side. Right. So we need to rearrange this to where it's y by itself equals the vertex form on the right. So the first thing I need to do is multiply both sides by negative 3. So when I multiply that by negative 3, that'll go away. So I'll have y plus 3 equals. Negative 3 is your a times x minus 2 squared. And then the last thing we need to do is subtract 3 from both sides. So that's my k term on the other side. So you'll have y equals negative 3 times x minus 2 squared minus 3. Everybody good with that? Y'all got that right? Good. Now you can answer all the questions. Okay, so it opens down because a is negative. The vertex is the point 2, negative 3. So since it opens down, it never crosses the x-axis, which means it never goes from positive to negative. The domain is all real numbers. It goes left and right, as far left as far right as the eye can see. The range is everything below y equals 3, so it's y less than or equal to negative 3. It's increasing on this interval. It's increasing all the way up to this point right here. So it's increasing for all the x's less than 2. It's decreasing for the x's greater than 2. It's never positive. Y is never positive on this function. It's always negative. Okay? The end behavior. Where is it going on both sides? It's going to negative infinity on both sides. So if they ask you about end behavior, as x gets smaller, it goes to negative infinity, and as x gets larger, it goes to negative infinity. Okay? Yes? Yes, they're always going to be the same. It's a problem. Okay. Any other questions? Okay, let's look at the next one. So look at this. What's my squared term? X or Y? Y. So you have to get what by itself? X. You want X equals. So if it's X equals, it's going to be opening either or what? Left or right. Which means, is it a function? No. You can't answer half those questions. Circles and sideways parabolas, they're short. Short problems. They're not functions. The vertex is, now this is when you have to be careful. Don't say it's -1, 2. It's not. The y coordinate for the vertex is -1. The x coordinate is 2. So it's 2, -1. And it opens left. Now, you do need to know where it crosses that x-axis. Oh, no, you don't. No, you don't. It's not a function. I don't care. Positive and negative doesn't matter if it's not a function. So, there's no max and no min. Because the top part goes all the way up to positive infinity, and the bottom goes to negative infinity. So there's no highest point and lowest point. There is an axis of symmetry. And that's what? Good. Y equals -1. I can say domain and range. What's my smallest value of x? Negative infinity. What's my largest value of x? 2. So my domain is x less than or equal to 2. My range, all real numbers. And the rest is irrelevant because it's not a function. Cannot answer those questions truthfully. Okay, so for this one, what's my non-squared term? X. So you have to get x by itself. In order for it to be in vertex form, you have to complete the square with y. Now, this is different than any other problem you've done with completing the square, because now we're completing the square and putting it back in vertex form. So, when we complete the square, we normally take our constant and put it on the other side, right? Okay. Well, now we have something else we have to put on the other side, too. We got to get everything else out of the way so that we can just complete the square with y. So, y squared minus 4y is going to remain on the left. Put everything else on the right. At the end, you'll move things back over to put it in vertex form. So you'll do y squared minus 4y plus blank. So that we can complete the square with that, right? Equals, move the 4x over there, move the 16 over there. So equals 4x minus 16, don't forget, plus blank. You add blank to the left, you have to add blank to the right. Now, half of 4 is 2, 2 squared is 4. We have to add 4 to both sides to keep it equal. What is that binomial? Y minus 2 squared equals 4x minus 12. Now, when you do this type of problem, what will happen is you'll end up with a binomial on the right-hand side that you can factor the greatest common factor out of. The reason why you do that is because that gets your A. Okay? So what's my greatest common factor on the right? 4, right? So, correct? Yeah. So we'll have y minus 2 squared equals 4 times x minus 3. See what I did there? Factor out of 4. Okay? Now, I'm going to divide both sides by 4. Now, there is another route you could take with this, which is fine. You can add 12 to both sides and divide by 4. That's fine, if you want to do that. But I'm going to divide both sides by 4, so that'll get rid of it over here, and that'll leave me with 1/4 over here, times y minus 2 squared equals x minus 3. And then add the 3 to get it back on the other side. So 1/4 times y minus 2 squared plus 3 equals x. That is the most complicated of these problems, okay? Where you have to complete the square and put it in vertex form at the same time. Your final exam will give you a problem like this, and then they'll say, what's h? So you have to get it from this to this, and h is 3. Or they'll say, what's k? And so you'll have to get it from here to here, and then say what k is. All right? So, any questions? Okay, so it's x equals, so it opens left to right. A is positive, so it opens to the right. The vertex is the point 3, 2. So 3, 1, 2, 3, up 2, and it opens to the right. And I'm not concerned with where it crosses the x-axis because it's not a function. It is neither a max nor a min. The axis of symmetry is y equals 2. The domain is all of the x's greater than or equal to 3. The range is all real numbers. And the rest of the answers we cannot answer because it is not a function. For number 7. Now for this one, we're going to do the same thing. We're going to, now if we could factor this, we could try to factor it right now, but we can't. So we're going to complete the square, so we're going to move that over. So y minus 1 equals, well, I'm going to leave a place for plus blank so I can complete the square on the other side. Equals x squared plus 4x plus blank. So half of 4 is 2. 2 squared is 4. So we're going to add 4 to both sides. So that's y plus 3 equals x plus 2 squared. Now, with the other one, we had something to factor out, greatest common factor on the other side. Here we don't. So all we have to do is subtract 3 from both sides, and we're done. Y equals x plus 2 squared minus 3. Now, it's y equals, so it's up or down. A is positive, so it opens up. Now, this one is a function. So the vertex is the point -2, -3. So -2, -3. Now, I need to know where it crosses the x-axis. But we do know it opens up, so I do know that this is going to be a minimum point. So I need to know where it crosses the x-axis because that is when it's going to change over from positive to negative. Now, you can use your calculator to figure out where the x-intercepts are. Or you can do it algebraically. When we use our calculator, we see that our x-intercepts, where it crosses the x-axis, are at -0.27 and -3.7. So -3.7, that's almost -4. 1, 2, 3, 4, so it's somewhere right here. And I'm going to mark that. That's negative. Well, I'm going to draw my line in the way. So -3.7. We're going to need that value. We're going to need this for the positive and negative when it switches over. And then -0.27 is right here. Okay? So my parabola. And I can go ahead and put my end behavior is going to be positive on both ends. The axis of symmetry is the line x equals -2. My domain is all reals. My range is all of the y's greater than or equal to -3. That's -3 on the y-axis. It's increasing for all the x's greater than -2. It's decreasing for all the x's less than -2. Now, positive and negative. It's positive when x is less than -3.7, or when x is greater than -0.27. Those are the two intervals where it's positive. It's negative between there. So when x is between -3.7 and -0.27. All right, same thing for this one. So I need to complete the square with y, so I'm going to move x and 4 over to the other side. So y squared minus 6y plus blank equals x minus 4 plus blank. Both of those go over there. Half of 6 is 3, 3 squared is 9. So we add 9 to both sides. So y minus 3 squared equals x plus 5. All I have to do is bring the 5 over there. So y minus 3 squared minus 5 equals x. So this either opens left or right. And a is positive because it's just 1. So that means it opens to the right. Which means it's not a function. So I'm not going to be able to answer all of these questions. All I can answer is the vertex, axis of symmetry, and domain and range. So the vertex is the point -5, +3. So 1, 2, 3, 4, 5, 1, 2, 3. And I know it opens to the right. I don't need any other coordinates because it's not a function. The axis of symmetry is y equals 3. The domain, this is where my domain gets broken up. My domain is all of the x's greater than -5 or equal to -5. And my range is all real numbers.